We do storage, or NAND storage, similar to what you see in an SSD. This is our latest new storage device. This little thing, about the size of my pinky nail, is a terabyte.
Hi Pixers, we are at Mobile World Congress 2025. It's been a long day. We are with, not from, we are with Chris from Micron, who's going to talk all about memory. Now, we spend our whole life with Edge AI, particularly with our design engineer community, talking about latency. And we are particularly going to talk about the world of mobile phones, where you play an incredibly important role, but where latency is just as important as it is in Edge AI.
Absolutely.
And memory and storage play a very important role, both in that world and in the Edge AI world. So, Chris, over to you.
Well, first, thanks for the opportunity. Chris from Micron Semiconductor, Micron Memory. I've been doing this for maybe not as long as you, but pretty close.
You didn't need to say that, but anyway.
Yeah, it's fine. But my focus is really on mobile phones and on the memory and storage that go on the mobile phone. And what the type of memory inside a mobile phone is called LPDDR, low power DDR RAM. Kind of like you're used to DDR in your PC. Ours is low power, and it's got to be low power so you have longer battery life.
Exactly.
Right? In addition to that, we do storage, or NAND storage, similar to what you see in an SSD. This is our latest new storage device. It is a UFS 4.1 based on our G9, or 9th generation, 3D NAND memory. This little thing, about the size of my pinky nail, is a terabyte. Pretty impressive that you can get a terabyte in any phone like this or any other phone that's out there.
Just to put that into perspective, to get that kind of thing even 5 years ago.
No, not a terabyte.
No, that's what I'm
saying. Yeah. Then you would be looking at somewhere probably around 256 gigabytes or so. This is pretty amazing what we're doing today, and I've been doing this for almost 30 years now. And when I started this, we were talking megabytes, and it's pretty interesting today to have something that small, that low power, that's a terabyte.
Yeah.
Right, pretty fun. Another, just to date myself a little bit, the LPDDR specs have changed over time. You can imagine there was an LPDDR1, LPDDR3. The most common LPDDR you see today in your phone is LPDDR5 or LPDDR5X, running anywhere between 7.5 gigabits per second to up to 9.7 gigabits per second. It used to be, when you'd come out with a new memory technology or faster memory technology before Edge AI, and I know a lot of your audience is really interested in Edge AI, the biggest benefit you would get is actually power savings. And the reason being, the faster memory would allow you to get the data from the memory to the processor quicker. The processor could do its work and then go back into standby mode faster. So you would actually see a big benefit from the speed impacting your battery life, just because that processor takes so much power of the battery and will be able to go down. Today, we're really, really excited because Edge AI is driving the need for higher performance memory. Right? In fact, what you see in this video that we showed you is a 7.5 gigabit per second memory versus a 9.6 gigabit per second memory will give you about a 10-second difference in a generative AI application. So what we did, our engineers, really smart engineers, we actually took Llama, and we got Llama running directly on a phone. We removed all access to any internet, anything else that would drive some type of latency or hiccup. And purely just based upon the operation of the phone, we asked the Llama LLM to say, what can we eat around Mobile World Congress? Where can we go eat? And here in this video, you can see it took 40 seconds for the 9.6 gigabit per second memory to go ahead and help process that, and it took about 50 seconds for the 7.5 gigabit per second. So it's super exciting to see the need for higher speeds, not just to save you battery life, but actually to process in 10 seconds. 10 seconds is something you notice when you're sitting there because you're hungry and you want to go for a walk and get something good to eat. So it's a really fun, exciting time to be an engineer again in this community.
Yeah, absolutely. So we talk about you talk about large language models. You talk about the processing on the edge, 32-bit micros. All these, you talked about generative AI, all these things that we're interacting with on the edge, and then you're describing a world where these are operating, and when you strip them down, you can improve just purely through memory efficiency. You're able to improve something that was being done in 50 seconds down to 40 seconds.
Right. And the only difference is the memory.
And the only difference is the memory.
That's right. Pretty exciting.
Yeah. So what are the implications then? So for our audience, in what are the implications moving forward? If we just sort of
Where are we going?
Where are we going? Because you said 4 years ago,
Yeah.
4 years ago, that was a quarter.
Right.
That could be done.
That's right.
And when we're doing videos, as we started at the start, it's just latency, 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 latency. It doesn't matter what the application is. There is absolutely no bandwidth. There is literally no bandwidth for latency. So from a company like Micron, who's going to facilitate, because 5 years ago, we wouldn't have been talking about memory. Memory was commoditized. Memory was just part of the system. It did a job, but it was all about the power of the CPU or whatever it was that you were sending the data to. All of a sudden, memory is absolutely a key part of that system. So that means as we move forward and we need higher speed, less latency, lower power, what you're describing, and I'm going to stop talking now, but what you're describing is, not this particularly, but everything that you're doing with memory is going to be absolutely the heart of that. So could you give us just some insight?
Sure.
And let's not talk about things like in 5 years' time, because that's just silly. But maybe...
It's going to come faster than people think.
Exactly.
Yeah.
Let's just talk 6 months, 18 months, of how you see that world changing.
So I see I'll just go 12 to 24 months. Can we do that? Right?
We can. That's absolutely fine.
You know,
that's
Mobile
absolutely
World Congress
fine.
is when everybody launches their big flagship phones. So
Yep.
about 12 months from now, you'll
Yep.
see a new set
Yep.
of phones coming out, and then another year after that, you'll see even more. Where I'm really excited about the phone is that the AI, the LLM, is going to be integrated into the daily usage of it. So today we think of AI as an app. I'm going to go open up an app, and then I'm going to use it to do static diffusion and build a picture, right? Or I'm going to open up an app and it's going to help me write some press, something like that. Maybe it'll help me edit something or like something like that. The future of AI in your phone is actually your digital companion. Your phone is going to have AI built into it where it's learning from you, learning your habits, and it's going to proactively interact with you in your day. There will be a runtime LLM running that we're starting to call an orchestrator. Okay.
That's a new phrase, an orchestrator. We've not had the orchestrator before.
And there will be another MML, a multimodal model, that's going to be taking input from you as you speak. It'll be taking input from your kind of traditional touchscreen. It'll be taking input from your watch,
Yep.
your GPS,
Yep.
your glasses.
Yep.
Right? It'll taking all this different input, and based upon this input, it's going to decide where you are, what you're doing, and what might interest you at that time.
Yes.
And then it's going to feed this context into this orchestrator, LLM, that's going to decide what to do with where you are and what you're doing at the time. So let me give you an example. Let's say you're shopping, right? In the United States, the Super Bowl was a very big, popular thing. Let's say it's around the Super Bowl. Your phone knows that you're having a Super Bowl party that upcoming Sunday. You're just shopping to go pick up some bread for the kids for school. It reminds you proactively to get the guacamole, because you're gonna need guacamole and chips for all your friends that are coming over to watch the Super Bowl that day. It actually, instead of you having to go
Based on past data.
based upon
past behavior.
knowing that you're going to have a party because
Yep.
it sees it
Yep.
personally knows you, and it's, by the way, it's on your device, so it's secure. The point is that your phone is going to proactively engage with you based upon knowing where you are, what you're doing, and help you get through things faster and more effectively. And moreover, it's going to be private. I don't necessarily want to send the fact that I'm at a store shopping for bread for the kids' lunch tomorrow to the cloud.
Back to a data center.
And I don't necessarily want the data center to know that what's in my text message is what's in my calendar. But I do want my phone to know it, because if my phone knows it, it can be useful to me. And it can say, hey, you picked up the bread, but I noticed that you didn't walk over to the guacamole aisle. Get the guacamole and chips, because you're going to want that on Sunday. Another example I like to give that's really easy for people to understand, GPS. GPS is an amazing invention that we love, right? We use it to get where we want to go, far away, nearby. It helps us understand where traffic is, etc. Yet, if you're in the UK and you're going to go across a long drive, you don't want to turn your GPS on right when you're leaving, because you know how to get 90% of the way. You want your GPS to proactively tell you if there's an accident on the way and take a different route. You want your GPS to turn on when it knows that you're getting close to the hotel, that it knows that you already
Well, it's going to get
reserved.
complicated.
But exactly, because you don't know exactly how to get to that hotel. But your phone knows that you're staying at that hotel. Your phone knows your location at that hotel, and your phone knows how to get there. And it can proactively tell you when you want to know how to get there. For me, living in California, if I'm driving to Los Angeles down Highway 5, it's a 5-hour drive. I'm ending up turning on my GPS 7, 8 different times to know, is there an accident in front of me? But I don't want to leave it on and draining my battery the whole time. I want it to tell me proactively what's going on. And that's what your phone's going to be able to do in very, very short order. It's going to be able to, you can be able to talk to it and have it interact with you, as you're already seeing with things that are going on in the cloud. But moreover, it's going to sit there. It's going to be your digital companion. It's going to help you understand what you want when you want it without even necessarily having to ask. And all of that is going to take faster memory, more storage, and more memory as well, because you, as I just described, you're going to actually have two models running in parallel at the same time. You need that to be low power, and you need to have enough memory to be able to store both of these models at the same time. So your phone today is 12 gigabyte if you're buying a pretty darn good phone. Your phone tomorrow is going to be 16 gigabyte. Very easily so you can get to 24 gigabyte in the next couple of years. And then beyond, as these models today, we're just starting to think about what's possible. And there's a bunch of young people out there, probably your audience, that are way beyond what we're describing right here, that are thinking about what's coming the day after tomorrow. And that's going to be really exciting to get to as well.
So to me, listening to you, seeing that device, talking about how you are facilitating this latency, for instance, when you were using the I think it was a text model in terms of cutting off nearly 10 seconds in a 40 to 50 second interaction.
That's right.
What you've described is a very complicated edge AI system, but the one that we don't have today. So how do you see, just finally, just as somebody who is facilitating these today, we're at Mobile World Congress, you're at the absolute heart, literally the beating heart of making sure these can do what they can do.
That's right.
And fulfilling the world that you've just described in the future. How do you see Micron as a supplier, or how do you see memory facilitating this edge AI, where, as I said earlier on the video, we just talk about latency all the time. So just we don't want to go into the 5 years, but in terms of even today, if you look how much the world has changed in the world of edge AI, how do you see that changing, for instance, for generative AI, for instance, that interaction? Because you've just described a world where we're talking to this every day. In edge AI now, we're talking about voice, we're talking about hand recognition, we're talking about text. Tell us how you see what you're doing today facilitating that future world.
Well, you can't do it by yourself, right? I love the fact that you talked about the heart. As a human being, we have a brain, we have a heart, we have all these different pieces. And I do like to think the memory as the heart. The memory is where your heart is, where your memories are stored. But you also have your brain, right?
Yep.
And so we have to partner with the brain. We partner with the folks that are making the application processors, the CPUs, the NPUs, the GPUs. We work very closely with them to understand where they're going, and they understand where we're going. And that integrated system with your heart and your brain working together, that's how your phone's going to get to where we need it to be. And then, of course, there's the software layers on top. And so our job is to go enable this fantastic hardware, all this great silicon that people are paying attention to again. It's a lot of fun to be in this world again. And then the software people can go see what's there and build it on top of it. And so you can name the companies. There's some big companies and some little companies that I just alluded to there. They're our partners. We work very, very closely with them, and we all have this common vision of where this is going. So it's really exciting.
Okay, so last question for our audience. When you're looking at an edge AI application, we'll just say they're the brain and you're the heart. What are the telltale things that they need to look for in memory performance? What are the things so we know that they are looking at, let's just be honest, it's a 32-bit micro dominated market at the moment. That's not to say it will continue to be, but for the moment we're looking at mainstream 32-bit micros, and that has to interact with memory. What are the things that they need to look for from your point of view, taking experience from this? Because you know that this is going to be reflected in edge AI. What are the 2 or 3 things, just that your experience tells you, that they should be looking for in the future so that they are building things that are doing the things that the phone are doing today?
I would say 3 things. First and kind of easiest to describe is capacity. You know if you have an 8 gigabyte, 12 gigabyte, or 16 gigabyte. phone, right? The designers of these phones certainly know what's going in them. And then they're looking at the capacity of these models, right? You have an 8 billion parameter llama file. That's going to take up a lot of capacity in the memory. So the first and foremost thing they have to do is make sure we have enough capacity. Second, I would say, is the bandwidth itself. As we just described earlier, bandwidth is directly correlated to the speed and the latency, first token, of an application in AI. Right, so we want to make sure we're making it fast enough so that the end user can actually use it, and they don't want to wait 2 or 3 seconds for something to pop up, right? So you need fast storage that loads it quickly into the DRAM and then can execute quickly with the CPU, right? So you need the speed. And then I would say the third is power. Because the last thing you want is have this great application that works on your phone for an hour and then you have to go charge your phone.
Yeah.
Right, so we have to balance that very, very carefully. And this is where our super intelligent engineers come in, working to make sure that we have the lowest power devices in the world so that in a battery operated environment, you can use this thing for a day or more.
Yeah.
Right, so those would be the 3 things to, as a design engineer, you're really paying attention to.
Excellent summary. So, I mean, just so we finish off, what you're seeing, you're at the beating heart of this. And this is what you're seeing there. I'm sort of looking at that as though that's an Edge AI system. There's nothing there. It's a blank table. But anyway, Edge AI, you're saying will be replicated. Those are the 3 things that you should be looking at. And at the heart of that is low power and latency to ensure that these things can do all the things they can doing. But if they take that as their lead, they can see that is possible because of what's going on there, and we all know that what goes on there is what's going to go on in there.
That's right. And at the heart of it all is Micron.
Is Micron, sorry,
That's
it's
right.
obviously Micron,
Yeah.
yes. And well, memory, latency. Thank you.
Thank you.
Chris.
Really nice to meet you.
Very good.
Thank you.
There we go.